Welcome everyone to this video about chapter 5.4 rational equations. If I'm going to compare this to previous paragraph, today we are going to be introduced to some new theories. Which ones? We're going to take a look at this part here, an inversely proportional relationship and so-called rational equations, also called in Dutch gebroken vergelijkingen, or you can say equations with ratios in them or fractions. The first part is about a so-called formula y equals a divided by x, with a being any number, right? In exercise 37, take a look at that yourself if you want to. You're encountering an example of an inversely proportional relationship. And it's quite a long time ago that we discussed what this was. Inversely proportional means omgekeerd evenredig. That means if one of the things becomes 2 times as large, the other becomes 2 times as small. And that is exactly the opposite thing of proportional, evenredig, which means if something gets 2 times as big, the other thing also becomes 2 times as big. For example here, when you multiply the number of painters by 2, by 5 or by k, then you divide the number of days by 2, by 5 or by k. If this thing becomes 2 times as big, this thing becomes 2 times as small. If I have double the amount of painters to paint something, then the number of days I need to complete that job is 2 times as small. Not 2 times as big, right? If I have double the amount of painters, I'm not going to use double the amount of days. In the table you have seen that the product of x, y is always 72. The product of those numbers is always going to be the same. Dividing both sides of xy equals 72 by x results in y equals 72 divided by x, and that formula corresponds to an inversely proportional relationship. Okay, whatever you say. What does it actually look like? What are we talking about? That's what I want to know. It looks like this. X, n, and y are inversely proportional. When multiplying x by a number k, then you divide y by k. Als x k keer zo groot wordt, dan wordt y k keer zo klein. Dan doe ik dit ding keer k, het andere ding gedeeld door k. And that will give me a formula. You can write it in this way, xy equals a, because the product xy is always constant. But most of the time you will see it in this formula form, y equals a divided by x. Why are those the same? Here you can divide the left hand side and the right hand side by x and you find the same form, right? And we can actually graph this as well. If I'm going to take a look, let's draw the graph of y equals 12 divided by x, make a table, fill in. Here you can see very well that the product x every time is the same, right? If x is 1, y is 12, 1 times 12 is 12. If you fill in x is 2, 12 divided by 2 is 6, and 2 times 6 is 12. 3 times 4 is 12. 4 times 3 is 12. 6 times 2 is 12, etc. This also always works. And the graph, if you're going to draw it, looks something like this. And such a graph is what we call a hyperbola, een hyperbool in het Nederlands. And then the relationship between those two things is called een hyperbolic relationship, een hyperbolisch verband. En daar gaan we in dit jaar nog niet heel erg op in, maar het is iets waar je in de 4e en de 5e meer in gaat verdiepen, wat precies een hyperbool is. For now you can remember that a graph that looks like this can be called an hyperbola. Okay, and it says GeoGebra example here. I think I'm going to show that during the actual lesson in Teams. Okay, remind me please. Maybe I forget this, but I don't think it's that nice if I'm going to show it here in this video. So with that, we're going to end the part about theory A. Good luck and see you next video for theory